Okay, so when the videos get too long, the uploading time grows exponentially, really. So how are we to do with definite integrals and substitution method, right? So we saw how we work to find antiderivatives with the U substitution, that backwards chain rule in 5.8. And then we saw what it means to throw in limits of integration. So we want to do the same thing, combine, find the antiderivative, and then throw in some limits of integration. Okay, so same thing, you're looking at this, and your job is to decide who is your U factor. Not that we actually could multiply this out, it's to the power of 2, so it's not that much. But if this was to the power of 10, you wouldn't want to sit and actually distribute all those exponents. All those parentheses. So I'm going to still use integration by parts on it. Even though algebraically, yes, it could quickly be simplified. Okay, so who should be U? I'm going to let you think about this for a minute. Who should be your U? And who should be your dV? And I'm going to tell you again, what you're trying to do is choose you one of these parts, one of the factors that's hopefully going to disappear by taking its derivative. So sure enough, it's really easy to decide the U should be X. Why? Because what's the derivative of U? 1, right? Or simply the X. 1 times dx or dx is the same thing, okay? All right, then means the rest of it, so this is your U, right? It's some part of it that we can make disappear in the second derivative, in the second integral, because the derivative is equal to 1. So dv is x minus 4 squared dx. That simply means v is the integral of it, the antiderivative of it. And the antiderivative of this is like any other power function. And even though we do have not just an x, but an x minus 4, just think about the chain rule, right? When you take the derivative of this, the 3 comes up, it's an x minus 4 to the power of 2. And what's the derivative of the inside parentheses? It's still just a 1, right? So that's why it works so nicely. All right, so that's your v. So we have all the parts, as I said. I'm going to maybe just write myself the formula up here to follow. U and the dv is the two functions minus the integral of swap them, v du. Okay, all right. So here, this is what I have. I have the integral from a u to a dv. And that's going to equal to what? U times v. What's u? U is x. What's v? V is x minus 4 to the third over 3. Yes, that's it. Minus the integral of what to what? Fine, still 0 to 2. In other words, also what? This, I'm going to have to plug in a 0 and a 2, but I won't until I'm all done to the end, right? For now, I'm still just finding the antiderivatives. The plugging in part goes at the end anyhow. So integral from 0 to 2 of what? V, which is this guy here, x minus 4 to the third over 3 times dx. Fine. No, there's no d. I was like, why are there two dx's? The integral doesn't have a dx. It has a plus k, if anything. So that's the integral of v, which is this. Du, by the way, is dx, right? So dx comes from du. That's what it is. Okay. So what I have is an x times x minus 4 cubed all over 3. So I just decided to throw it both over 3. Minus, is this something whose antiderivative we can find easily? Okay, so it's 1/3 from over 3 times the antiderivative of this is x minus 4 to the fourth over 4. Yes. And now that we are done, do we have to change the limits of integration as we did in the u substitution problem? No, because as you see, in the integration by parts, even though we're dealing with u's and v's, these functions, once we substitute, we already substitute them in terms of the x's that they equal to. So this story at the end is already all about x's. So these limits of integration 2 and 0 were about x. So we keeping the same ones. It's not like I have a u in here so I can find the new limits of integration. So because the story is still about x's, there's no reason to change, or there's no reason, we should not change the limits of integration. So all I'm going to do is plug in a 2 first. So it's 2 times 2 minus 4 is negative 2 cubed over 3 minus 2 minus 4 is negative 2 to the 4th. I'm going to combine these two over 12 minus, plug in a 0. Oh, 0 times who cares what? It's 0. Minus 0 minus 4 is negative 4 to the 4 over 12. So put this in your calculator. I believe I have the answer. I'll let you start plugging in those values. But this is what I'm going to get. That's a negative 16 thirds minus 16 over 12. That's a 0, and minus minus is a plus. 256 over 12. Put all of that in your calculator and you're going to get 44 thirds. Okay, so yes, the challenge for many of these problems is simply to make sure you those minuses can mess you up quite a bit. So you might know all the integration by parts and integration by substitution and all antiderivatives and derivatives, and then you mess up on a little minus sign and it drives you nuts because you don't get the correct answer and you're like, I thought I got this. So yes, I know it's getting a little technical with the minuses and it's easy to mess up. So keep that in mind. You probably just messed up on a little minus sign. Check up on your computation again. So don't freak out just yet. Okay. All right, so here it is. Let's try one more. Integration by parts. Did I say that we don't need a backwards quotient rule? Why don't we need a backwards quotient rule? Because every quotient can be written as a product, right? Between one of the factors and then the reciprocal of the bottom. So 1 over e to the 2x is an e to the negative 2x, by the way, right? So just like that, we turn this quotient into a product, okay? All right, so who should be our u and who should be our dv? What do you think? I'll let you pause there for a minute, pause the video and decide who's your u and who's your dv. So again, pick u, something simple that's gonna pretty much disappear. And sure enough, it's not quite going to disappear completely, but at least when you take the derivative of this, there's going to be no more x's left. There's just the 2. Okay. Now, also, not that we couldn't find the antiderivative of either factor, but you also need to make sure, because that's your dv. And what do you find out of dv? You find back v by finding the integral. So this should be something that you know how to do. So the antiderivative of e to the negative 2x is itself divided by negative 2. Here, I'll write it one more time. Okay, so we have the formula in mind. Maybe you're getting used to it. So this is what I have. The integral of u dv is u times v. So 2x times e to the negative 2x over negative 2. So again, u v, right? Which we have all parts right here. Minus integral back of what to what? V, which is e to the negative 2x over negative 2 times du. And what's du? Is 2 dx. Okay, I can live with that. These are now things that I can multiply. Before, these two functions were functions we didn't know how to multiply. They're different types of functions that cannot be multiplied together. So let's just put this together. So 2x, I need another pencil. The 2's go away, so I'm left with a negative, right, from here, x e to the negative 2x, minus the same thing here. These 2's are going to simply cancel out. And the antiderivative of this, don't forget there's a minus. I'm going to write this minus here. This is this minus. This is this minus I copied. And the antiderivative of e to the negative 2x is e to the negative 2x over negative 2. So this whole thing, now that we found the antiderivative, we still have to throw it between 0 and 4. So that's the only difference. So we go all the way, just concentrate on finding that antiderivative, that definite integral, right? And then at the very end, fine, if there are limits of integration, throw them in. I'm going to fix this just a little bit more though. So that's going to be negative x e to the negative 2x minus. There's 3 minuses right here. That's still 1 minus 1/2 e to the negative 2x. Sure, you can write it over 2, leave the over 2 over there. I just want to get rid of all these minuses before, again, I mess up on a minus sign and I don't know why I'm getting the wrong answer. So keep track of that. So I'm going to plug in a 4. E to the negative 2 times 4 is negative 8. Minus 1/2 e to the negative 8. Minus, plug in a 0. Well, if I plug in a 0 times e to the who cares what, that's a 0. Minus 1/2 e to the negative 2 times 0, that's a 0. So that doesn't go away. Remember, e to the 0 equals to 1 and not a 0. So that's what I have. I have a negative 4 e to the negative 8 minus 1/2 e to the negative 8. Minus is a plus. Again, 1/2 e to the 0 is 1/2. If you want, you can put, by the way, see how these are actually, in fact, like terms? Some e to the negative 8s and some more e to the negative 8s. That's negative 4.5 or negative 9/2 e to the negative 8 plus 1/2. You can leave this. This is what we would call an exact answer. Or you can put it in your calculator and come up and see what that actually approximately equals to, but that's totally fine. All right, so that's integration by parts. Again, the most important part, the key is who do you choose to be u and who do you choose to be dv. And your u should always be something you wanted to disappear in the second integral, because once you take its derivative, it's much simpler. Maybe it's completely gone. Maybe your x's are gone. Always you choose ln x to be your u because you want to take the derivative of ln x. Right, to make it go away, it's just the 1 over x, and then you can combine these functions. So what also has to happen in the second integral that you still have to evaluate, this should be something easy to find, right? So even if you should still have a product between your v and your du, they should be functions that can be multiplied together, okay? All right, so again, out of u, you make du, out of dv, you make v, and now you have all the parts in that formula, right? Okay, so I have one more application for you, and that's something back out of section 5.7 about the continuous stream of income. So the continuous stream of income was going back to our PERT formula, okay? Our PERT formula, was about what? You investing a principal amount of money, P, for some time T at an interest rate R, and you just leave it there, right? And at the end of this time, multiply all this together and you figured out how much money you made, right? Out of this amount that you started with. Now, as we saw in section 5.7, what if you want to keep adding on every year? So in 5.7, let me write this down. P was what? I believe $2,700 every year. So it was really a rate of growth by itself. So the rate of P wasn't a constant fixed amount at the beginning, but it was a rate at which we put money in every year. So what had to happen back there too, even though in year one we adding 2,700, yes? And then we let it grow for a year, but then the second year we're like, well, I have another 2,700 laying around. Let me add it on, yes? So now I have my 2,700 plus a little bit of interest, yes? And I'm adding in this other 2,700. So I'm letting the whole thing now grow. And you keep adding on every year. So your P, your amount, is really a rate of 27 constant amount every year. But let's say, and so how did we figure out then if this P is changing? How did we figure out this amount? It was an integral from 0 to how many years we're leaving it in for, which was the 2,700. This was your principal, right? E to the whatever rate you had, yes, T dt. I'm not writing the same T here because that's a variable T. It changes from 1 to 2 to 3 to 4 to whatever we made that stop to be, right? Your T. So that should be fixed. This is changing, right? Every year we're putting in more and more and more. So this is what we call the future value, right? And we also called it PF. And we had a second formula for it. We talked about present value, and you've done some homeworks on this. And the present value was also used to basically kind of figure out, well, what would be a fair value of a business right now, right? So the present value right now that would give me $2,700, right, every year for this many T years. So the present value, we found it by doing the same thing, except for what? We divided by e to the RT, so we had a negative exponent, remember that? So these were your two formulas that we played with in section 5.7. Now what we want to say is this. Now that we have integration by parts tool to be able to compute more difficult integrals, the question is, can we make this not a constant? Can we make it a function of T? So maybe it varies. Maybe you can put some money in 1 year, a different amount in the second year. It shouldn't be random there. There should be able to be a function that connects them. So what if we invest a different amount each year? Say our principal is a function of T, which is 1,000 T, which means what? In year one, how much money are we starting with? At year one, we're putting in $1,000, yes? Year two, how much money can we put in? Well, 1,000 times 2, 2,000. So I'm upping my game every year, right? So year three, I can put in 3,000. Well, who knows how far we can up this game. But let's say, right, there's a pattern. And every year I put in a little bit more and a little bit more, and I'm not keeping it as a constant. So our principal is not a constant rate of 2,700 per year, but it's changing. So if I want to find both present value, future value, let's find the future value, even though your homework for some reason keeps asking for the present value only. Here is the future value. Maybe I should make you find both. I always like better future. So what else do I need? I need to know how long, right? So let's say we want to keep doing this for how many years? 10 years? All right. And let me give you an interest rate. So let's say I'm giving you 5%. Might be easier to figure out. So the bank gives you 5%. You keep putting more and more money each year for 10 years. What's going to be your future value? How much money will you have? That sounds like a lot. Well, it's the integral from 0 to 10. Yes. Of what? is this function, which is 1000 t. Yes, that's your principal. Future means you keep investing it, you're going to get more. So we keep the exponent positive, right? Present value, we make the exponent negative. Okay, so PF is this, okay? What do I want to do with this? I want to find the integral. Now, as you see, this function here is made up of what the problems in these sections were made up of. A product between two functions. This is not a constant. It has a little t hidden in there. So these are two functions that cannot be multiplied together. So it's kind of like your 2x e to the something x, right? The x, this is a product of two functions that cannot be multiplied together. So we have to use integration by parts. That's why we are revisiting these problems at this section. So to use integration by parts, I need to play my game of what kind of game? I need to play my u dv game. Okay, I need a different pencil. Okay, so I need to play my UDV game. Okay, so who should be U? I'm sure you've guessed it already. The U should be, where is this? I need the room. U should be what? This 1000 t, just like the 2x in the previous problem, by the way. So du, what's the derivative of this with respect to t, is 1000 dt, yes? So du dt, right, same thing, we throw the dt over. Okay, now on the other hand side, who should be our dv? It's the rest of it, so that's your u, and that's your dv. So dv is e to the 0.05 t dt. So that means v itself is the integral of it. And the integral, the antiderivative of it is e to the 0.05 t divided by 0.05. And when you divide 1 by 0.05, you should be getting 20. But I will double check. Yes, that's 20. E to the 0.05 t. All right, that's your v. Great. So I'm going to play my game. So the integral of this, of u dv, is u, which is 1000 t, times v, which is 20 e to the 0.05 t, minus the integral from 0 to 10 still of what? V, which is 20 e to the negative, to the 0.05 t, that's u, that's v, du. Where is du? Du is 1000 dt. Okay. So one more time. That's your u. That's times v minus the integral of v du, right? Again, according to our formula, these are all the parts. So I'm going to put this together. We're almost there. That's going to be a 20,000 t e to the 0.05 t minus the integral of this is going to be 20,000, and that's again coming from that 20 times 1,000. The antiderivative of this is e to the negative 0.5 t divided again by another 0.5. Okay, so take this and plug in a 10 and a 0, and let's see what we get. So I'm going to plug in the 10. So that's going to be 20,000 times 10 times e to the 0.5 minus 20,000 divided by 0.05. I'm going to fix that. So 20,000 divided by 0.05 is itself 400,000. Okay. E to the plug in a 10. So that's 0.5. That's it. Minus plug in a 0. Well, the good news is when I plug in this part here, a 0, that's a 0. Minus 400,000, remember, e to the 0. Okay, so let's see if we can put this. I'm going to put this quickly in my calculator. So that's 200,000 times e to the 0.5 minus 400,000 times e to the 0.5. Minus minus is a plus 400,000. So I hope I did this right. Fingers crossed. So I end up with a 70255.74 or 75, let's say. So by the end of these 10 years, you're going to have $70,000, 255, okay, and 75 cents. Okay, so the question is, how much of this